Hello everyone, we are a graduate team from Xidian University IPIU Laboratory, and it is a great honor to share our scheme in the CELIA object detection competition with you here. After preliminary data processing, the data set contains 90,116 training set samples, 6,105 verification set samples, and 6,779 test set samples. In our preliminary analysis of the data, most of the CELIA targets occupy a large pixel distribution in the figure, but at the same time, we also found that among the parameters of the dataset, there was a parameter named EXIF that would cause the abnormal angle of the image when loading, so that it could not correspond to the mask. Therefore, in the processing stage, we cleared the EXIF parameter to prevent the occurrence of anomalies during training. In addition, we made some extensions to the dataset, adding 4 additional datasets to enrich the training set. Combining these datasets with the training set and the validation set of the competition's dataset, a total of 51,721 samples will be obtained. Due to time, only the thematic segmentation network of mask former was selected in this competition. The specific reason is that its mask segmentation method is very suitable for the concept of CELIA target detection in our opinion. At the same time, we used these data enhancements in training and for recasting respectively. At the same time, in the ablation experiment, we found that the cutting size should not be less than 80% of the maximum size. Otherwise, it may be difficult to converge. We judge that the reason is that it may lose the significant target samples, thus confusing the network. In the prediction stage, we adopted the method of voting to obtain the final result. Firstly, we tried the 2 models and 512 and 720 resolution respectively, and adopted the EMA strategy to obtain 2 EMA models. For these models, the scaling scale of 0.5, 0.75, and 1.0 of the training image scale were used to make multi-scale prediction. 2 models predicted at the same scale were hard-voted to obtain the prediction results under different resolutions. Finally, we will make the intersection of the masks predicted by the 2 scales to obtain the final prediction result. In the end, we got a score of 92.91, which we attributed to the following schemes: expanding the dataset, choosing a suitable model, adopting a reasonable training scale, adopting a multi-scale prediction, adopting a hard voting scheme, and finding the intersection of the final results. That's all we shared this time. Thank you for listening.